So I would like to welcome Damon McCoy next. So Professor McCoy is an assistant professor at New York University in the Computer Science and Engineering Department. His focus is on empirical measurements of the socio-economics of cyber attackers, privacy-enhancing technologies, and security of cyber physical systems. So let's welcome him.
I'm having a little bit of difficulty. Yep, thanks, Popple. Locating where my slides are. So I'll just begin before my slides come up. And so what I'm going to be talking about today is essentially how traffic is being differentially handled when it comes from Tor exit nodes. And this is very collaborative work that was done in part by a lot of students. Bono, David, Sadia, who's here in the audience somewhere, Mobeen, Shrikamph, and then Vern, Stephen, and myself. And we all had some ties to either Cambridge, Berkeley, or ICSI while we were doing this project. And so just to kind of quickly motivate this problem, right, when a regular user sees the web, normally they're relatively satisfied. They can get to most of the major sites on the internet fairly well. What's happening is that Tor users in particular are oftentimes seeing kind of error messages or stuff like that. They're essentially being blocked or filtered somehow when they're using Tor. For those of you that aren't familiar with Tor, very briefly, it's a tool that allows users to essentially more privately browse the internet. So it source routes your packets, encrypts them through basically 3 routers, and then the final router, the exit router, then contacts the service that you're intending to contact. And so there's 2 flavors of censorship in Tor. The more traditional one that's been fairly well studied is this censorship of blocking users from using the Tor network. And so this has been fairly well documented and studied. However, there's this second form of censorship where, right, the user can use Tor, but then when they try and contact services, they're blocked by the services. And so this is what we're going to focus on, because there's really no great studies on this prior to ours. And so how websites block Tor is, it's relatively easy. So, right, the user, they have their 3 hops. That final hop is the exit node. All of these exit nodes are publicly known. There's a public directory of all of the Tor servers and the ones that are flagged as exit nodes. And so there's, I think, even open source plugins that will give you a full list of exit nodes so that you can readily block all IPs, exit IPs of the Tor network. As part of our study, we're going to try and understand this blocking of Tor at the 2 main layers, so at the networking layer and at the application layer. The networking layer is slightly easier. The application layer is obviously harder because there's a lot of different ways that you can block at the application layer. And so to begin with, to measure the network layer discrimination, what we did is essentially tried to probe servers on port 80, so the web port. We did these scans from 2 different vantage points, and we used a tool called ZMap to basically scan the entire internet. We did it from 4 Tor exit nodes in different regions of the world, and we also performed basically baseline scans from 3 control nodes, one at the University of Michigan, one at the Cambridge, and one at the University of Berkeley for our control nodes. And so we performed these scans over the course of several months. And the first thing is, right, we need some metric to define what we consider to be the footprint of the web that is blocking Tor. And so we basically define this as, right, the set of the web that successfully responds to our control nodes but does not respond to the scans that are executed from the Tor exit nodes. However, this, right, proves challenging. And so the students came to realize very quickly that the internet is very hard and unstable to scan. And so the first challenge that we ran into is, right, packet loss. And this is relatively easy to overcome by just simply sending redundant probes. And if the packet loss is kind of transient, one of those probes will get through. The harder thing to deal with is that, right, there's parts of the internet that are relatively unstable. Both in time, they change very rapidly, and they also change kind of by spatially, meaning by the location that you're trying to connect to. So if you're in Europe, parts of the internet might look very different because of connectivity issues than, say, if you're a user in the US. And so there's just these parts of the internet that are weird and poorly connected or very unstable. And so we came up essentially with two different footprints of the internet. We had one that encompassed basically the quasi-stable part of the internet. And this is what we called our lax web footprint. And this is the ones where they at least responded once to one of our control probes. And then there's the more stable part of the internet. This is about 50% of our web footprint where they just reliably responded to all of our control probes. And so we built up two kinds of models based on these two different web footprints. And kind of the punchline is using our strict web footprint, we see that about 1.2% of the web blocks Tor exit nodes consistently. And to drill down into this a little bit, we'll first quickly look at the lax footprint. And so for the lax footprint, we see about 13% of the web blocks Tor nodes. And we see at the top there, we see two of the major Chinese backbone internet providers are blocking Tor exit traffic. And this is not surprising because China also blocks on the user end as well Tor. And then below that, we see some kinds of, basically server hosting kinds of ISPs. And they block somewhat, but not as heavily as the Chinese backbone ISPs do. However, when we move to the strict footprint, the Chinese backbone ISPs vanish because they're not stable. That part of the internet is not temporally or spatially stable. And so that doesn't get included in the strict footprint by and large. And so what we're left with is mostly kind of more stable ISPs that are doing this server hosting. And among these, we see ISPs like Rackspace, DreamHost, and so on, that look like they're fairly consistently blocking Tor exit traffic to the servers hosted within their ISPs. Okay, so this is what kind of differential treatment of Tor traffic looks like at the network layer. And so the other layer that we're going to look at, and perhaps the more interesting layer that will kind of drill down into what this has in terms of impact to Tor users, to look at the application layer discrimination that's going on. And so for this, we, and by we, I mean the students, set up some probing to basically contact web servers, both as a normal user not using Tor and as a user using Tor. And again, we find that for the Alexa Top 1000, it's largely reachable by a user in Berkeley, and there's at least some parts of the Alexa Top 1000 that are not reachable when you're using a Tor. And so kind of the punchline of our findings from this is that we find that about 3.6% of the Alexa Top 1000 blocks Tor. And so these are sites like Yelp, Craigslist, LinkedIn, Cloudflare, which is actually a fairly big one. So Cloudflare, unfortunately, at this point, hosts to offer kind of CDN and anti-DDoS protection, hosts a large segment of the internet. And so they're one that's blocked, and the other large CDN is Akamai as well. And they show signs of also blocking Tor exit traffic. And so a lot of this isn't kind of uniform of blocking all 900 approximately Tor exit nodes. A lot of this is kind of, they block some of the Tor exit nodes, but not all of the Tor exit nodes. And so I won't really have time to go into this, but essentially the punchline of this is that that blue region on top there are websites that kind of consistently block virtually all of the Tor exit nodes. So these are websites that are probably explicitly blocking Tor. And then that middle segment are websites that block some of the Tor exit nodes, but not all of them. So they're kind of ad hoc blocking of Tor. And when we kind of dug into this, what you can see is that there's largely two flavors of application level blocking of Tor. One of them is that the sites, say like Yelp, is explicitly, they have a list of the Tor exit nodes and they're blocking them. So they're explicitly blocking Tor and all of Tor exit nodes. However, we see a lot of these other websites, ones like the ones that are protected by Cloudflare or Akamai or Google, let's say, that aren't blocking all of the Tor exit nodes. They're simply blocking the Tor exit nodes that they perceive as abusive. And so they have these anti-abuse systems that when they see abuse coming from an IP address, add them to a block list of sites. And this kind of produces this effect that we call fate sharing, where all users of that Tor exit node basically share the same fate of being blocked, because there's a few bad apples that are generating abuse out of these IP addresses. And so this kind of shows the limitations of abuse-based blocking and how they don't kind of mesh well with Tor, where basically every IP address isn't an individual user. You could think of it more as kind of a huge kind of NAT, almost like an ISP that's hosting, thousands of users behind each IP address. And so the other thing we note is that our measurement of application blocking is nowhere near perfect. So there's examples like Google, where Google doesn't block you at the home page. They block you when you actually try and do searches. And so this kind of blocking becomes very hard. There's a similar instance in Wikipedia where Wikipedia blocks editing. So they allow you to view Wikipedia, but they block editing of it. And so there's all this other kinds of differential treatment at the application layer that's even harder to find, where they're not blocking the home page, but they're blocking you when you try and do some action. And the other thing we find is that some of it isn't outright blocking. Some of it is they actually show you like a CAPTCHA, let's say. So Cloudflare is one that does this very commonly. They don't outright block you. They instead show a CAPTCHA. And this, becomes frustrating because users of Tor basically are turned into these large-scale CAPTCHA solving kinds of services. And so Cloudflare in particular took notice of complaints of this, and now essentially they turned Tor into its own country. So Tor is now a country in Cloudflare, and you can select it, and if a user of Cloudflare wishes, they can select Tor and whitelist all of Tor's IP addresses so that they don't get caught up in this kind of abuse-based blocking. So some progress on this issue. However, this is obviously not a perfect solution because, this kind of circumvents the anti-abuse measures that were in place at Cloudflare. And so the solutions are hard. One idea is perhaps to kind of build in some idea that, there's going to be these bad apples in systems like Tor, and perhaps, the exit nodes and things like that can do a better job of preventing kind of large-scale abuse emanating from Tor exit nodes. So this is one idea, but it's obviously tricky because it's hard to find the abuse, it's hard to block the abuse. It's then difficult to say what is and what is not allowed from a Tor exit node and things like that. So this becomes kind of murky. And the other idea is this idea that people have been kicking around for a long time of kind of some way of not blocking the entire IP address, but blocking particular users. But the problem is, that in Tor, as it's designed right now, you can't differentiate users, and that's by design to increase their privacy. And so the problem with all these kinds of anonymous blacklisting solutions is that they all degrade anonymity in some way for the user. But if the choice is being blocked or degraded anonymity, some trade-offs might be made in that area. But again, this is difficult solutions. And so to kind of wrap up, we see at the network layer that about 1.2% of the web is currently blocking Tor, and at least 3.6% of the Alexa top 1K sites are also blocking Tor. And that this is, unfortunately, it looks like an increasing issue for Tor users, but a difficult one to have a great solution for. So I'm not sure how much time I've left, but if I have left any time, feel free to ask any questions.
Any questions?
So on Alexa, have you done anything with using any other kind of security or been successful at using Tor directly out of the Alexa interface?
What do you...
Well, you were talking about Alexa.
Right, with the Alexa top 1,000 sites?
Yeah.
We just simply use that as a seed list of sites to probe to see if they were blocking Tor.
Oh, okay. Just if you ask Alexa to go somewhere.
No, not Alexa. Let me clarify. So Alexa is a list of heavily trafficked sites. And so the Alexa top 1,000 is supposed to be a representation of the 1,000 most popular websites as perceived by Alexa.
Different Alexa, overloaded term.
Right, yeah,
Thanks.
sorry, yeah.
So on the Cloudflare, I'm kind of surprised to see that they're actually going to completely block Tor, and they've declared it as a state to kind of block it. Can you speak to that a little bit? Because Cloudflare also offers services that are very questionable to people that come in and open up an instance and launch a DDoS on someone that they don't like. So I'm wondering if you could kind of explain the rationale, even though
Right.
they turn on and offer other kinds of services themselves.
So by default, Cloudflare does not explicitly block Tor. What's happening is that some of the Tor exit node IPs are accruing a poor reputation in their reputational system. And there's kind of a default setting, like in the middle, there's like a slider of, I'll tolerate IP addresses with this amount of abuse. And you can set it to low. I think by default it's like medium, and then you can set it to like high, where, right, depending on the level of abuse. And so that's where the blocking is coming in for Cloudflare, is not explicitly. And so I would see this not as Cloudflare wanting to block, but of providing a kind of not so elegant solution to whitelist Tor nodes if the operator of that site doesn't wish to have this fate sharing kind of occur. So I would see this as actually a good thing on Cloudflare's part, that they were trying to be positive and trying to allow those that wanted to no longer block the segment of Tor IP addresses that are accruing bad reputation because of abuse metrics.
We can have one more question, if anyone has.
I come out of the realm of industrial security that the gentleman from Cisco was talking about, where safety is paramount, where human life is at stake. And so from a developer of a web application, I'd want to know why I wouldn't block Tor. I would, if someone wants to look at my site with anonymity, that right there is a flag that would indicate something suspicious.
This definitely is an argument that springs to mind of a lot of people. I think there's a lot of studies that kind of have dissuaded this notion. So there's been studies looking at, say, like e-commerce sites, and they've shown that Tor visitors are just as likely as normal visitors to make purchases from these e-commerce sites and things like that. And so I think that there's, this is an area where we need more studies, but I think the initial studies indicate that users of Tor are oftentimes no worse in terms of abuse than the normal internet population. And so I think explicitly blocking Tor exit nodes and explicitly blocking anonymity doesn't buy you a whole lot of security in the end, because the attackers, oftentimes if they're more skilled attackers, are going to use more stealthy IP addresses than Tor IP addresses. And so I think that taking that stance oftentimes doesn't afford you a lot of security.